a simple structure like two parallel plates. If you have a piece of wire and separate it out and connect it to two plates, you just realized a capacitor. So that means you have a wire here, you have a wire here, you connect a metal plate here and you connect a metal plate here. You just created a capacitance between them. How the electric field of a single infinitely long plate is going to come in place here to understand what is going to be the electric field. Clearly you can see that there are three different regions, right? A region to the left of the plate, a region in the middle of the plate, and the region which is to the right of the plate. And notice that both these plates are infinitely long. All this guy is having a plus charge, whereas this guy is having a negative charge. So in total, if you were to encompass the entire volume, the plus and the minus cancels each other, so the charges are all neutral. But it's just that in this plate, the plus charges are available, and in this plate, the negative charges are available. Now, if you were to find the electric field at these three regions, what do? We can use superposition, isn't it? Now that we know if you have a plus charge, what is the electric field here and what is the electric field here? For example, I'm going to use red color for this. And if it's plus in this region 1 for rho s, at this point, due to this plate, the electric field be to the left. So the plus charge is going to be repelled there. So now, how about at this point, the electric field? It's going to be to the right, because electric field is the force experienced by a unit positive charge. You bring in a plus charge here, 1 plus 1 charge here. Of course, it sees a plus charge and gets repelled. So as far as this is concerned, this is how the electric fields are going to look like. Now things get interesting for the negative charge. Yeah. So what will be the electric field at this location? To the left, because you imagine a plus 1 charge coming here. Plus 1 charge will get attracted to this negative plate. So this is how the direction of this is going to be. Then how about if I have a plate, a point here? Will it be to the left or to the right? It's going to be to the right, because the plus 1 charge will get attracted there. Now, how does the superposition work? The superposition works as if that if I were to have only the negative charge, any point on the right of that is going to have a leftward facing. So if I define this is to be my x, so this is going to be in the negative x hat direction, and this is going to be in the x hat direction. Whereas for this guy, this is going to be in the plus x hat direction, and this is going to be in the minus x hat direction. Interestingly, what will be the electric field due to this guy over here had this not been present, had this surface had not been present? The electric field due to this guy would still be in this direction, right? It will still be in this direction here, regardless of the height where it is from this plate, regardless of the distance where it is from this plate. It's going to be rho s over 2 epsilon naught. Similarly, over here, we're going to have, regardless of what the distance is, this guy is going to be like this, which is rho s over 2 epsilon naught in the x hat direction. Now, when I bring in both the plates together, interesting thing happens, right? This guy cancels off with this guy. The plus and the minus cancels each other. So what you end up having in the region 1 is zero electric field. Similarly, this guy will cancel this guy off, and you end up having 0 in region 3. What happens in between the two plates? You're having rho s over 2 epsilon naught here, and again rho s over 2 epsilon naught here. Both of them in the x hat direction, the same direction. So what happens to the total electric field? It's going to be rho s over 2 epsilon naught plus rho s over 2 epsilon naught, which becomes rho s over epsilon naught in the x hat direction, if I were to choose this to be my x hat. So the superposition works, where if you were to have this plate alone, you have rho s over 2 epsilon acting in the plus x direction, and rho s over 2 epsilon naught in the minus x direction to the any point to the left. So similarly, if you have this plate alone, you see this phenomenon happening here. But now when you combine the two together, you see that this term and this term will cancel each other. This term and this term will cancel each other, whereas this term adds up together, and that becomes rho s over epsilon naught. Rho s over epsilon naught in the x hat direction. So just now you figure out what is the electric field between two parallel plates.